Hello! So let's get you ready to dominate your final exams. So here we have a quadratic function. We have f of x is equal to 2x squared plus 8x plus 5. We're asked to take this quadratic and put it into vertex form. So what in the heck is vertex form? Well, recall that vertex form of a parabola is going to be of the form a times x minus h quantity squared plus k. Now if it's in that form, then the vertex is going to be at the point h comma k. So h comma k is your xy point. That's going to be the vertex of the parabola. So we start out in standard form. Recall standard form is ax squared plus bx plus c. To go to vertex form, we want to complete the square. Now how we can go about completing the square is we take our quadratic function here, we think of it as equal to 0, and we can then just go ahead and move the constant to the other side of the equation. So we have here 2x squared plus 8x plus 5. We can write that as 2x squared plus 8x is going to be equal to negative 5. Now, just make sure that the a value, or the coefficient on x squared, the coefficient on the quadratic term is 1. In this case, it's 2, right? The coefficient, the number in front of x squared is 2. We want that to just be a 1, or we want nothing in front of x squared. So if it's not going to be 1, we can just go ahead and factor it out. But since we already moved over the constant to the other side of the equation, well, we can just factor a 2 from the left-hand side of the equation. So we go ahead and we factor out a 2 here. What do we have? We pull out a 2, and we have 2 times, well, 2 times what is 2x squared? Well, 2 times x squared is 2x squared. And then 2 times what is going to be 8x? Well, 2 times 4x is 8x, so we have a plus 4x. And now that's still going to be equal to negative 5. Now, why did I leave a gap? Well, because we're going to add something that's going to create then 3 terms. So we have 2 terms right now. We want to add something here that's going to create a perfect square trinomial. Or in other words, it's going to create 3 terms that's going to factor into something squared. It's going to have that x minus h quantity squared. And how we can do that is just once we have the coefficient on x squared is now 1, we look at this part here, we just take half of the coefficient on the linear term, or half of the number in front of x. So the coefficient on x is now 4, half of 4 is 2, and then 2 squared is 4. So we take half of 4 is 2, and then we square that to get 4. So we're going to be adding 4, but again, that's half of 4, and then we square that. So half of 4 is 2, 2 squared is 4, and then this factors as, well, it's going to factor as, you can add it in a second, but we added something to the left-hand side of the equation. So we have to add the same thing here to both sides to keep it equal. So we added a 4, right? So add a 4 here. No. That is the common mistake, is to add the exact same thing. You add 4 here, you add 4 here. You do add the exact same thing, right? You want to keep this equation equal. You want to add the same thing to both sides. But this is not 4. This is not 4. I mean, this is going to be 2x squared plus 8x, the same thing we have right here. But then this is really going to be a 2 times 4. So that is really going to be 8. Right? It's really going to be 8. So we have to add 8 to this side as well. And now this factors as, well, if you don't see it right away, it's going to be x plus 2 times x plus 2. But whatever half of this was, half of 4 was 2, it's always going to be x plus that, or x minus that quantity squared. And it's the same sign. So here we have a plus, it's plus 4, half of 4 was 2, so therefore this x squared plus 4x plus 4 factors as x plus 2 times x plus 2. But x plus 2 times x plus 2 is x plus 2 quantity squared. So we still have the 2 out front here. And this is going to factor now as x plus 2 times x plus 2. That's x plus 2 squared is then going to be equal to, well, negative 5 plus 8. That's 8 minus 5, which is 5, 6, 7, that's 3, right? So therefore, we have 2 times x plus 2 squared equals 3. To go to vertex form, just bring the 3 back over, and we have 2 times the quantity x plus 2 squared minus 3. So there we have it in vertex form. What is the vertex? Well, the vertex is at the point h comma k, so it's always x minus h squared plus k. So here we have x plus 2, so h is actually negative 2. This is like x minus a negative 2. And then we have minus 3, which is like plus negative 3. So the vertex is at h comma k, but h is actually negative 2 and k is negative 3. So the vertex is at the point negative 2, negative 3. Now, is that going to be a maximum or a minimum? Well, you can think here for a second and say, well, where is negative 2, negative 3? That's going to be, well, negative 2 is somewhere to the left and down. It's going to be in this third quadrant. And are we going up or down? Well, the a value always tells us, is our parabola a happy face or a sad face? If a is positive, it's definitely a happy face. It's going up. A is 2, right? And the a value was 2 in vertex form and in standard form. That a value is not going to change depending on what form you're in. It's 2, which is positive, meaning we go up. So we go up, and therefore, if it goes up, it has a bottom point. Therefore, it has a minimum. So it has a minimum value, and the minimum value is going to be at negative 3. It's the output there, so it's going to be the y value. It occurs when x is negative 2, but the minimum value is at negative 3. Now, we basically completed that the question here. We took our quadratic, put it into vertex form, identified the vertex, and identified if it had a maximum or a minimum. In this case, it has a minimum of negative 3. But if you wanted to go ahead and solve the equation for x, that's finding the x-intercepts. It's basically finding the values of x that make the output 0. That is finding the x-intercepts. Looking at this thing, you know the y-intercept is at 5, right? Because if you plug in 0 for x, then you have, well, just 0 plus 5. So when x is 0, y, or f of x, is equal to 5. So the 5 is going to be the y-intercept. How do you find the x-intercepts? Well, to find the x-intercepts, you can try to factor it. This, I don't think is going to factor very nicely at all. Maybe it would. I'm not sure. I don't think it's going to factor. You could always use the quadratic formula, or you can actually solve it by completing the square. So we do the same steps to get to here by completing the square, and then instead of bringing the constant back over to go ahead and put it into vertex form, you want to just isolate the square and then square root both sides to kill off the square. So if we have a 2 in front, we can divide by 2, and what we would have, x plus 2 quantity squared is equal to 3 over 2. So 3 halves, and then we could go ahead and square root both sides, and we have x plus 2, right? The square root of something squared is just whatever the something is. That's going to be equal to, it's always plus or minus the square root of whatever that is, right? Because a negative squared is still positive. So when you square root both sides of the equation, you have to account for plus or minus the square root of 3 halves. Well, the square root of 3 halves is the square root of 3 over the square root of 2. So you could write it as the square root of 3 over the square root of 2. If you wanted to get rid of the square root in the bottom of the fraction, you could by multiplying this by square root of 2 over square root of 2, because that's just 1. And then what you have is square root of 3 times square root of 2, which is actually square root of 6. Because remember, if you have a product under your square root, you can go ahead and split. So square root of 3 times square root of 2 is going to be, well, square root of 3 times square root of 2 is square root of 3 times 2, which is square root of 6. But then over square root of 2 times square root of 2 is just 2, right? Square root of 2 is irrational, but square root of 2 squared is 2. So that's going to be just square root of 6 over 2. So basically what you get is you get x plus 2 is equal to plus or minus, it looks like the square root of 6 over 2. Just subtracting 2 to both sides, we get that x, put it up here maybe, that x is going to be equal to negative 2 plus or minus square root of 6 over 2. So the two solutions then would be negative 2 minus square root of 6 over 2, or negative 2 plus the square root of 6 over 2. So therefore, yes, we do have these two solutions. We can see them, right, by graphing it. If the vertex is below the x-axis and it goes up, it's going to hit the x-axis. So we have those two solutions, and trying to solve by factoring, not going to be nice, not going to work for you, because the solutions are actually not nice numbers. They're irrational numbers, but you can find them also by completing the square. Calculator and get ready to